All right, today we are going to talk about section 1.9, opposites and absolute value. To use opposites and absolute value is our objective. To warm up, let's review a little of what we did yesterday with these number lines. So we are going to name the point that is the graph of the given number. So number 1, we've got -2 and 5/8. Keon, which point is the graph of that number? Point E, I would agree with that. Point E shows us the graph of -2 and 5/8. What about number 2, -0.2? Ellie? C. Wonderful. It's just after 0, just to the left of 0. All right, and what about number 3, 2.25? Jamal? That would be point D. Nice of them to go in order. All right, paired points on the number line that are the same distance from the origin but on opposite sides of the origin are called opposites. Some examples would be -1 with 1. Those are opposites. 0 with 0. 0 is its own opposite. And -6.8 with 6.8. Okay, I think you're probably pretty familiar with opposites. In most cases, one is positive, one is negative, except for the case of 0. So as it says, the opposite of 0 is 0. The absolute value of a number is the distance between the graph of the number and the origin on the number line. The absolute value of a number is denoted by absolute value of A. So A is inside those bars. Those are the absolute value bars. When you write those, make sure that you make them long enough so that they don't just look like a number 1 or an 11. Okay, they should be a little bit taller than the numbers. If A is positive, then the absolute value of A is just equal to A. So we take the absolute value. It's always going to be positive. So the absolute value of 8 is 8. That is the distance between 8 and 0 on the number line. All right, if A is negative, then the absolute value of A equals A. So if the absolute value of -8 then would be a positive 8. I know the notation is a little confusing here. I would rather they put like a negative A in there, and then you see that it ends up just being positive A again. Absolute value is always going to be positive, except for the case of 0, because the absolute value of 0 is 0. 0 is neither positive or negative. All right, for our first few examples, we are just stating the opposite of each number. So number 1, the opposite of 3. Well, I need hands. All right, Jalen. -3. The opposite of -7, Connie, is +7. The opposite of 0, Kelby, is 0. All right, this next set, we are simplifying absolute values. So on number 4, the absolute value of 5. Natalie is 5. The absolute value of negative 2. Lexi? Is a positive 2. That's the distance from 0. And on number 6, the absolute value of 0. May? 0. Is 0. Alright, this next set, there's a little bit more to simplifying them. So on number 7, what this means is we are taking the opposite of 3 plus 2. So first, what should we do? Yes, we do parentheses first. So inside the parentheses, what do we end up with? Maybe someone I haven't heard from today. Jariel. 5, wonderful. And then we take the opposite of that, and we get negative 5. Awesome. Number 8, the way I would read this in my head is the opposite of negative 3.5. The opposite of negative 3.5. Anyone able to help me out there? That I haven't heard from? Kelby, do you want to go again? No? Jalen, want to go again? No? Wow, nobody wants to help me out, huh? You just like notes to take as long as possible. Jamal? What?
3.5.
Oh, wonderful. The opposite of negative 3.5 is a positive 3.5. Alright, on number 9, we have to take the absolute value of negative 4. Then we also have to take the absolute value of 7. And then we're going to add them together. So, the absolute value of negative 4. Still looking for someone new to tell me the absolute value of negative 4. Shannon.
4.
Wonderful. Thank you so much. Plus the absolute value of 7. Mikkel. What's the absolute value of 7 is going to stay 7. We add them together to get 11. Alright, we need to evaluate if t equals negative 4. So on these we first have to substitute, and then we will simplify. So, essentially we just did this problem. We have the absolute value. We plug in negative 4 for that t. And after a painful discussion, we finally found out that the absolute value of negative 4 was 4. The end. That's all that there is to that problem. On number 11, do not drop this negative sign that's out in front. Just because the t is also negative does not mean that this negative just disappears. So we have a negative, and then in for t, we plug in a negative 4. So I would read this as the opposite of negative 4 plus 9. Ellie, can you help me out with the rest of this problem?
I have no idea.
So the first part would read the opposite of negative 4. Can you help me out with that part?
4.
Wonderful. So we would change this to a 4. We're still adding that 9. The last part of that is just to add those together. Same hands all the time. Connie, can you help us out with adding those? All right. Not here. Natalie.
It's going to be 13.
Thank you. All right, on number 12, once again, that negative sign out in front stays out there. We have to plug in the negative 4 for t. So make sure your bars are nice and tall so they don't look like ones. The first thing we need to evaluate is the absolute value. So that minus sign out in front is going to stay there. And we're just going to replace the absolute value of negative 4. Lexi, what's the absolute value of negative 4?
4.
Wonderful. And then, really, that's it. Right? The answer is just going to be negative 4. We don't have to rewrite it again. On this page, we are going to simplify for this last set of problems. As always, we start inside of our parentheses. So I'm just going to leave that minus out there. And instead of 12 minus 12 in my parentheses, Houston, what goes in there? A 0. So now this problem would read the opposite of 0. Nevaeh, what's the opposite of 0?
0.
Wonderful. All right, we've got multiple grouping symbols on 14. So we start on the inside, and then we work our way out. So we start on the inside. We've got a 4 in there. We're taking the opposite of that. So I'm going to leave all that other stuff alone and just focus on taking the opposite of 4. Jakeem, what's the opposite of 4? Negative 4. Now this reads the opposite of negative 4. Tariana, what's the opposite of negative 4?
Is it 4?
It is a 4. Questions, concerns so far? All right, on that last section, once again, we've got two absolute values that we have to evaluate, and then we will add them together. May, what's the absolute value of 2.6?
2.6.
Beautiful. Plus, Adrian, what's the absolute value of negative 0.4? The absolute value of that would be a positive 0.4. And then we have to add them together. Keon, what do we get?
2.2.
Since we're not using calculators yet, if you need to, you can do this addition off to the side. Okay, 6 plus 4 gives us 10. So we carry the 1. That adds up to a 3. And when we add decimals, the decimal point just lines up and comes down. So our answer here would be 3. If you put 3.0, that is also correct. All right, on these last two problems, we are going to translate each statement into symbols. Similar to what we were doing earlier this week. Number 16 reads, the absolute value of 6 is less than the absolute value of negative 20. So, I will just talk through these. You're just going to read through them and do what they tell you to write. The absolute value of 6. We would represent that with a 6 inside absolute value bars. Is less than. Yesterday we talked about the symbol for less than. It kind of looks like an arrow pointing to the left. Something like that. The absolute value of negative 20 is the last part that we need. So we have a negative 20 inside those absolute value bars. On 17, it reads, the opposite of negative 3 is greater than the opposite of 2. When we are representing the opposite, we use a negative sign. So the opposite of negative 3. We use two negatives because we're taking the opposite of a negative. Is greater than. The greater than symbol kind of looks like an arrow pointing to the right. The opposite of 2 would look like just a negative 2. You could put the 2 in parentheses if you want to, but you don't have to.